So guys, in this video we are going to design the circuits for simple Boolean expressions or Boolean functions. Now first of all, what is a Boolean function? What does this term means? It simply means a combination of inputs on which the outputs depend. Okay, so what is a Boolean function? A combination of inputs. For example, if I write some function f of a comma b, that is nothing but a bar b or a b bar. This is a Boolean function, right? This is a and b are our inputs, and this is the combination. Okay, now let's start with designing some basic Boolean functions. The first one is this one. Now it says x whole bar or y. So how we can design it? Here we have our input x, here we have our input y. Now we want x in inverted form, so we will place a NOT gate in front of x to get x bar, and now this y will go as the second input for an OR gate. From here we get x bar or y. Okay, so this is our x bar or y. Now next example, that is example 2, is xy bar or x bar y. Now we discussed this in our logic gates video. We know that this is equivalent to XOR of x and y. Okay, now how to design it? So first of all we need two inputs. First one is x, alright, and the next is y. Now first we want x dot y bar, that means the NOT gate in front of y. Now the ANDing of these two. Okay, now the second function demands the inversion of x, so here we go with the inversion of x. Now with the ANDing of y, so y goes here. Now both the functions are further ORed with OR gate, so here we have our OR gate to produce the final output, that is nothing but x XOR y. Okay, now next question. So question 3 is this one. Now we'll apply De Morgan's law in a second bracket. It will become x bar or y bar. Okay, now distributing this over this bracket, we will get this expression. Alright, now we know there is nothing common between x and x bar, so this is 0. Similarly here it is 0, and this is applying commutative property, it becomes x bar y, and now the rest of the expression is rewritten as it is. Okay, now we just discussed this in our previous question, right? We implemented this one right here. Okay, now let's implement it in a different manner this time. In this question we will implement it using these two brackets. First we need the ORing of x and y, so this is an OR gate, this is an OR gate, this is our input X, this is our input Y. Now we this is expanded form of this one. All right, now we will just take X from here and Y from here and send them as input to a NAND gate. Right, from here we are going to get X or Y, and from here we are going to get X dot Y's whole bar. Now finally they both are to be ANDed using the AND gate. From here we are going to get our required output, that is X or Y dot with X dot Y's whole bar, right, which is equivalent to X dot Y bar or X bar dot Y, which is nothing but X XOR Y. So you can see that we have implemented the same Boolean expression using different combinations of logic gates, right? We can use any design, whatever strikes you at the moment. So that was all about the designing.